Okay, here are some of the questions that you wanted me to work through off of the Module 5 quiz. So on this top one, right, we're looking at using the properties of exponents to be able to simplify this. Notice that the top, the whole thing is raised to a negative power, and on the bottom, the whole thing is raised to a negative power. And the way I like to think of negative powers is, I kind of think about it with my kids. So I had, once we finished the basement, then we had, some of my kids that were like, negative. They were unhappy. They were upstairs. And so if they went downstairs, they were going to be positive. They were going to be happy. And then after a while, one of my kids that was downstairs was negative, didn't want to be down there because there were spiders and all sorts of stuff that she didn't like. And so then she wanted to go upstairs. So that's kind of the way that I think about this. So let's first take care of these negative exponents that are on the very outside. When you do that, that means that really that you would flip everything on the top and put it downstairs. And then this will no longer be a negative 4, but a positive 4. But the trick to this is we haven't changed anything inside these parentheses yet. So this negative 5 hasn't changed yet. So let me show you. So on the top, we're going to put this on the bottom now. So we'll have 2x to the third power, y to the negative fifth. Remember, we haven't changed that yet. We'll do that in a minute. All raised to the positive fourth power, right? Because we're just moving this downstairs. Now we want to do the opposite and move this other one upstairs. So to do that, I'll have x squared, y squared, z squared, all raised to the positive second power this time. It was negative. Now we're changing it to be a positive. All right, now that we have positive exponents, I'm going to distribute those through. Now, granted, you could have back here just distributed that negative exponent through to everyone, but usually it gets really messy the more negatives you have to deal with. So I suggest you don't distribute that negative through. So then the next thing, if I distribute the power of 2 through to the top, I'll get x to the fourth, y to the fourth, z to the fourth, and then on the bottom, I'm going to distribute my power of 4 through to everybody, and make sure you remember 2 is given a power, x to the third is given a power, and y to the negative fifth. For some reason that 2 gets forgotten about, but it is separate and we need to do that. So we'll have 2, I'm just going to write it right now as 2 to the fourth power, so you can remember that's what we did. And then x to the third to the fourth, power raised to a power, we multiply those, so that would be x to the 12th. And then the same thing with the y, but this time it's a negative 5 times 4, so y to the negative 20th. Okay. Now, we still have an unhappy y downstairs, so this y definitely wants to move upstairs to be happy. So I'm going to move this guy and just that one upstairs. Okay. So when I do that, then I get x to the fourth, y to the fourth, and then I'm going to put this y to the positive 20th now upstairs. Remember, it was negative downstairs. It was unhappy. We're going to move it upstairs to make it positive and happy. And then z to the fourth. And then on the bottom, if I simplify this a little bit more, 2 to the fourth power is 16. And then I still have x to the 12th. And then it's not all the way simplified yet because we need to make sure that we get all of our whole numbers together, our x's together, our y's together, our z's together, right? So we did part of it by getting all positive exponents, but we're not quite done yet. All right, so then the next thing that we're going to do, we see that there's x to the 4th on the top and x to the 12th on the bottom. Now, you could do the property that says do 4 minus 12, but then that's going to give you another negative exponent on the top. And so I suggest to students to think of it this way. Look at your x's and say, where are there more x's? Well, there's more x's on the bottom. So that means that my x's are going to remain on the bottom. Let me just do a little side note over here. Like if I had something like this, x to the 5th over x squared, right? Then that's really saying x times x times x times x times x, right? And then I have 2 x's on the bottom. And then remember that I'm dividing things out. X divided by x is 1. X divided by x is 1. And then I'm left with 3 x's on the top, right? And so that means that my answer is x to the 3rd to this, right? And notice there was more x's on the top than there were on the bottom. How many more? There were 3 more. All right, so now let's do that same thing, but with this, right? X to the 12th is bigger than x to the 4th. How many more are there? Well, it looks like there's 8 more, right? So x to the 8th is going to be on the bottom, and our x to the 4th now, right? We got rid of our x's and put it down here. All right, we don't have anything to combine with our whole number 16, so that stays on the bottom. It's not negative or anything. There's no negative exponent, I should say. So it's not going to flip upstairs. It's going to stay downstairs. All right, then what about our y's and z's? Well, it looks like I have a y to the 4th and a y to the 20th. And when they're connected by multiplication, I add those together. So y to the 24th is on the top, right? And now those y's, right? We got rid of those, right? We took care of them. That's why I'm just canceling these things out. So they're just crossing them out so you can see that those are the ones we've already done. And now my z to the 4th is all that's left, and it's on top. It has a positive exponent, so it will also stay on top. So that is what you get for your answer when you do that. Now, with this one, when you're simplifying a square root, you need to remember a couple of things about this. So, I think an easy way to be able to simplify these square roots is to take the numbers, the number that's inside, and do the prime factorization for it. So let me try that over here, just out to the side, do a little side work. So if I have 27 and I break it down, that's 9 times 3, and then 9 will still break down to 3 times 3. So 3 times 3 times 3 is 27. Right, so if I rewrite this as that negative 3 is on the outside, and then I have the square root of 3 times 3 times 3, right, that's my 27 part, and then there's 5 c's, so c times c times c times c times c. And so remember, this is a square root. I'm going to write a little 2 here to help us remember. It's kind of like an invisible 2 that's always there on square roots. Down here on cubed roots, right, it already puts it in. But if it's empty, then it's a square root. And this is telling us how many we have to have in our group in order for it to come out of the square root. So meaning here, right, I've got a pair of 3's, so that means a 3 gets to come out. Okay? And then this 3 doesn't have anybody to buddy up with, so it actually has to stay inside shell. That square root shell there. Looks like there's a pair of c's, so a c gets to come out, and another pair of c's, so another c gets to come out. But then this c doesn't have anybody to pair up with either, so it is stuck still inside there. Now, when things come out of the square root prison or jail or whatever you want to call it, right? When they come out, they're going to be multiplied by the number that's already out there or just multiplied together. So let me write it down this way. So we already had a -3 that was out there. We had another 3 that came out. We had a C that came out and another C that came out, right? These things here are what came out. And then still left inside was 3 and C. And then if I simplify this a little bit more, -3 times 3 is -9. C times C is C squared. And then square root of 3C. So that would be my answer to this one. Okay, but remembering when it's a square root, things have to come out in groups of 2. Now, a little bit different than that on number 12 is notice that this one is a cubed root. And let me go ahead and let me just erase this part. We'll come back to it. That was just another one that I wanted to go over with you, but let's make room here. So on this one, since it's a cubed root, right, we have to have 3 of the same in order for that to come out. So let's again do just a little side work over here and do 128. When I break that down, you know, maybe you're like, I don't know exactly what divides into it, but it's an even number, so I know that I'm going to have 2 times something, right? And that 2 times something would be 64, right? And then 64 can break down to be 8 times 8. And then 8s break down to be 2 times 2 times 2. And another 2 times 2 times 2. So wow, we've got a lot of 2's here, right, that we're dealing with. In fact, we have 7 of them that make up our prime factorization. So if I write that over here, back inside, right, so I've got my cubed root this time, and I said there was 7 2's, so that's going to be 2 times 2 times 2 times 2 times 2 times 2 times another 2, right? And so now again, remember, since it is a cubed root, right, then things have to come out in groups of 3. So there's a group of 3, so that means a 2 gets to come out. Here's another group of 3, so that 2 gets to come out. But this 2 doesn't have anybody else, so it has to stay inside. You can't make another group of 3. So when we come up with our answer for this then, right, we've got 2 times 2 that gets to come out, so that's 4. That's on the outside. And then cubed root of just a 2 that's still stuck inside. And that would be your answer for that one. Okay. And then the last one I wanted to talk about, I just noticed that factoring seemed to be kind of an issue, and so I wanted to make sure that we maybe talked about some of the factoring questions. So let me just do one of these factoring the trinomials for you. So like if you have x squared plus 15x plus 56. All right, and so you're thinking to yourself, what times what equals 56? And I always tell my students to make sure that they're working organized when they're figuring out these factors. So I want to know what multiplies to be 56, right? That adds to be 15. And so it takes a little bit of time, and if you don't see it right off, that's fine. Just work organized. So I'm thinking, what times what is 56? So I know 1 times 56 is 56, all right? And then I can see that it ends, 56 ends in an even number, so I know 2 times something, right? 2 times 28 is also 56. And then if I think, well, does, 56 can you do 56 divided by 3? No, that won't go in evenly, right? What about 56 divided by 4? That one works, and that's not one that people, usually think about, but 4 times 14 is also 56. And then 5 doesn't work, 6 doesn't work, but 7 does. 7 times 8 is 56. And I know that I have all of my factors, because notice how these are, I worked organized as I was going down, right? 1, 2, 3, 4, 5, 6, 7. And then I look to the other side, and since 7 is right next to 8, there's no numbers in between them, then I know I have all of my factors, because then I know 8 times something, 14 times something, 26, 28 times something, and 56. All right, so now I'm just looking to see which one of these factors would add to be 15. Well, the only one that will work on that would be 7 and 8. And sometimes you have to ask yourself, would this, which one of these factors would add or subtract to be 15? Well, on this one, since we have both positives here, then we know that when we factor these, they're actually going to factor to be plus sign on it. And sometimes it just takes a little bit of practice there. But so x times x gives us our x squared. And then we just figured out what times what is 56. That adds to be 15. That's positive 7 and positive 8. So that's something that you can kind of play around with a little bit more. Make sure you're understanding factoring is one of the most important things that you need to get down. You're going to be doing a lot of it in your upcoming math classes, okay? I hope that helps. Have a great night. Bye.